Good day, grade 11s. Let me welcome you to another lesson. In today's lesson, we will focus on analytical geometry. So let's go through the scenario together. So in the diagram, point B, this point B is a point on the y-axis. Okay, and then we're given 4 vertices A, B, C, and D. These belong to the rectangle. They are vertices of rectangle A, B, C, D. And then we also have 2 diagonals BD and AC, and the angle of inclination with respect to the line DC is alpha, and we're also given this angle. So in the first question they say determine the gradient of line segment CD. So in other words, they want the gradient for this line segment here, CD. So we can substitute these points, the coordinates of these points, into the gradient formula. That is MCD is equals to YC minus YD all over XC minus XD. So YC 0 minus YD 6 all over XC, that is 3 minus 7. So this is negative 6 over negative 4, and this is 3 over 2, or in decimal, as a decimal number, that is 1,5. So the next question says calculate the size of alpha. So in the picture, alpha is the angle of inclination, and the angle of inclination, alpha, is measured from the positive x-axis to the line CD. So we need to use the angle of inclination formula. That is, the tangent of the angle of inclination is equals to the gradient of line segment CD. So we found the line segment, the gradient, to be 1.5 for the line segment CD. So we can just substitute it. So that's 1,5 is equals to the tangent of alpha. So if we take 10 to the other side, it becomes 10 inverse of 1,5, and this is equals to 56,31 degrees, correct to 2 decimal places. So the next question says determine the value of y, and y in the given case here, y is the y-intercept of the point A. So recall that the line segments CD and AD are perpendicular, meaning that the angle between them is 90 degrees because ABCD is a rectangle. So we can apply the formula that states that if you multiply perpendicular gradients, you get -1. That is MAD times MDC is equals to -1. This formula applies to gradients that are perpendicular. This is the case in the given scenario. So we can say YA minus YD all over XA minus XD times, and we have MDC. We found MDC to be 3 over 2. So we can substitute that. It is 3 over 2 is equals to -1. So YA is Y minus YD is 6 all over XA is 4 minus 7 times 3 over 2 is equals to -1. So 4 minus 7 here is -3. I'm going to write -3. So now I'm going to multiply the left hand side and the right hand side by the reciprocal of 3 over 2. Y minus 6 over -3 times 3 over 2 times 2 over 3. And what you do on the left, you need to do on the right. So now I've gotten rid of the 3 over 2 on the left hand side because those cancel out. So now we have y minus 6 over -3 is equals to -2 over 3. So now we can use cross multiplication. -2 minus -3 is +6. is equals to 3 into y minus 6. So we can say 6 is equals to 3y minus 18. So if you take negative 18 to the other side, you get 24 is equals to 3y. Divide both sides by 3. Therefore, y should be equals to positive 8. And the last question says, calculate the size of theta. So they want us to calculate the size of this angle. I can actually write theta here. Reason being is because these two lines AB and CD are parallel, and we have our Z shape. So it means that these angles are alternate angles. So that's why I can write theta there. So theta is measured from this point to that point, and we have alpha here. So we can actually find the third angle, call it beta, and we can say that beta is equals to theta plus alpha. And we can actually find beta. We can find beta by using the angle of inclination formula. Remember, angle of inclination is measured from the positive x-axis counterclockwise to the gradient of the line, and in this case it's AC. So let's use the angle of inclination formula to find the value of beta. We can say tan of beta is equals to the gradient of line segment AC. So tan beta is equals to YA minus YC or over XA minus XC. So we found YA to be 8 earlier on, so we can say 8 minus YC is 0 all over XA is 4 minus XC is 3. So this is 8 over 1, which is equals to 8. So tan of beta is equals to 8. So now we can say beta is equals to tan inverse of 8, and this gives us 82.87 degrees correct to 2 decimal places. So now, because we know beta is equals to theta plus alpha, we can say that theta is equals to beta minus alpha. And now that we have beta and we have theta, we can find, we have alpha. Now we can find theta. So theta is equals to beta minus alpha. Beta is given as 82.87 degrees minus alpha is 56.31 degrees. So this gives us 26.56 degrees correct to 2 decimal places. Thanks guys for watching. See you in the next one.